Alright guys, quickly, so what I want to talk about in this video here is just a quick brief overview of this idea of indices and the laws that we use to apply with index notation. So before we start off, getting this idea of what is an indice. Indice is an index, it's a power. So here, it's these small numbers that we raise a number to. Alright, so I have 2 to the power of 5. And what I say, because I say it's 2 to the power of 5, 2 is the base, and 5 was its index. Over here, b is the base, and 7 is its index. And what we left here, like 2 to the power of 5, all that really means is it's 2 times 2 times 2 times 2 times 2. You can see here I've got 2 multiplied. There were 5 2's there. So that repeated multiplication is just index laws. It's powers. So if I go 2 times 2 times 2 times 2 times 2, that's 2 to the power of 5. Much the same as b to the power of 7 is b times 7. Sorry, not b times 7, is b times b times b. And I'll repeat that pattern 7 times. Over on the right here, this 2, it's by itself. It's not raised to a power. So what we assume is that it's to the power of 1, right? If there's a number by itself, it's to the power of 1. This phrase here is actually just 2 times a times a times a times a. You know, that idea that there's 4 repeated multiplications of a. So the 2, no power was written there, so I assume it's the power of 1. A is the base, and 4 is its power. So let's go look through at some of these patterns and laws that we talk about indices. So the first one we're going to talk about here is this law of multiplication. When I multiply numbers with the same bases, what I end up doing is adding their powers. So we can see that 2 and 2 both are the same bases, so I add their powers. 5 plus 3 was 8. Over in this question here, I multiply my numbers. 2 3s were 6. And then the a's were the same bases, so I end up adding their powers. With this fraction, remember fractions are another way of describing division, and we'll talk about that in a minute. But with this fraction, the first step I want to do is I want to simplify this numerator. So f to the power of 2 times f to the power of 3. Well, these are the same bases, so I just add my powers. Another example I haven't written, but it's one to think about, is what happens if I have m to the power of 3, n to the power of 2 times m to the power of 5. Well, the only thing with the same bases are those m's. So that's going to be m to the power of 3 plus 5 times n to the power of 2, which just becomes m to the power of 8, n to the power of 2. That poor little n, it had nothing that was the same base of it, get left alone. Moving on to the next index law, which is the opposite. If I multiply numbers with the same base, I must add their powers. Well, division is the opposite of multiplication. So if I divide numbers with the same bases, I subtract their powers. So again, this idea of both the same base, so I take away their powers. Same base, 7 take away 4, I'm left with 5 to the power of 3. If I mix it up, if I include numbers and pronumerals, I do 8 divided by 2, which gives me 4, and then whatever the same base, I do that subtraction. Now, remembering that this a, it has no power written there, so we assume, or we know, it's actually a to the power of 1. So we get that 3 minus 1. On the right here, it doesn't matter if my power is a negative power. You can see over here, this 2, there's nothing to divide the 2 by. 2 divided by 1, because there's an imaginary 1. Well, not imaginary, there's a 1 written there. I'm just too lazy to write it. 2 divided by 1 it stays 2. Now, my same basis, I do subtraction. I do 3 take away -2. And remember, when two negatives are next to each other, it becomes a positive. So I end up with 3 plus 2. So that one becomes 2g to the power of 5. Now remember earlier, I talked about this, I looked at this example. Let's continue to finish that example. So remember from earlier, we had this, and f, we ended up getting f to the power of 5. Now remember I said fractions are just a way of division. So there are no numbers to divide. So I leave that. Remember there's the number 1 in front, so I just leave that. Now I look at my f's, my 5 and my 7. Well, 7 take away 5 is 2. However, the majority or the most f's were at the bottom here. The 7 were in the bottom. So 7 take away 5 is 2. I have 2 left in the bottom, which means I have no f's left in the top. You could think of it as f to the power of 0 is left in top. And anything to the power of 0 equals 1. And we'll see that later on. But because there's no f's left in top, I don't write it. So this answer becomes 1 over 3f squared. If you turn over that page, the next index law that we have is the power of a power. I have a to the power of m, and that is all raised to the power of n. Well, when I have a power of a power, these guys just multiply together. Happy days. Let's look at those examples. If I have a to the power of 4, and then that power of 4 is raised to the power of 3, I just do 4 times 3. End up with a to the power of 12. And the reason being is I have a to the power of 4 times a to the power of 4 times a to the power of 4. You can see a to the power of 4 has been multiplied together 3 times. That 3 and that 3. And remember 4 plus 4 plus 4, because I'm multiplying numbers with the same base, is 12. So what we end up doing is multiplying 4 3s are 12. When there's more than one thing inside the brackets, so x to the power of 3, I'm going to do 3 times 7. And it's going to give me 21. But remember, this number 2, it's there. And remember, if I've just got a number or an algebraic letter by itself, there's actually the power of 1 there. So what we're doing is 7 times 1, and it gives me 2 to the power of 7. Now, x to the power of 21, I don't know what that is, but 2 to the power of 7, I know what that value is. I can express that on my calculator. So now we get our calculators out and type 2 to the power of 7 equals, and it's 128. So 2x cubed, and get all of that to the power of 7, we end up with 128x to the power of 21. Same thing next door here with this example over here. The 2, we'll remember 4 to the power of 4 by itself is just 4 to the power of 1. X by itself is just to the power of 1. So that's why we have 2 and 1 times 2. I got a little bit lazy there, but 1 times 2. 4 squared, and we can evaluate that on a calculator. It's a number, that's 16. 1 times 2 is 2, so that becomes x squared. Y was to the power of 4, so 4 times 2 is 8. So we end up with 16x squared, y to the power of 8. So in summary, power of a power ends up multiplying our powers all the way through. One of my favorite ones, this index law. Anything to the power of 0 is equal to 1. However, you need to be careful as what is the base of our 0. So nice and simple to start off with, m to the power of 0 is 1. Next one across here, notice the 0, it only applies to m. So m is the only thing that becomes 1. So what we are left with is 2 multiplied by 1. Well, 2 multiplied by 1 is just 2. Moving the next bracket across, the 0 applies to everything in the bracket. Everything inside that bracket becomes to the power of 0. 1 times 1 times 1. So because everything was to the power of 0, it simplifies to 1. Now be careful, let's combine some of those ideas. On the right hand side here, only the m is to the power of 0. So the 2 stays the same. M to the power of 0 becomes 1. So this phrase here is just 2 times 1. The next thing I asked you to multiply it by was this bracket. But everything in that bracket was to the power of 0. So that whole figure became 1. So this statement here just becomes 2 multiplied by 1 multiplied by 1, which equals 2. Finally, fractions and negatives. Probably one of the more difficult ones. Very similar to the power of 0. We need to be careful as to what the power is applying to. And whenever you see a negative index or a negative power, that just means we've got a fraction somewhere. And anything that the negative applies to, whatever is the negative, it goes in the denominator. You can see a by itself to the power of negative m becomes 1 over a to the m. Looking at this first example here, x to the power of negative 3. Only the x has the negative applying to it, so the x goes in the bottom. Anything that doesn't have the negative applied to it stays in the top. So m has no power, x has the power of negative 3, so the x cubed goes in the bottom. This next bracket across, everything's to the power of negative 4. So everything goes in the denominator. And remember, 2 to the power 4 is something we can evaluate. We write that on our calculator. This one here, 7x times 14x cubed to the negative 1. Everything here goes in the denominator, so I write it in its denominator. But then when I look at it, now I apply the division laws that we did earlier. 3 take away 1 is 2. The most x's were in the bottom, so I write the x in the bottom. And I need to simplify 7 over 14. 7 over 14 equals half. If we're not sure what 7 over 14 equals, we can type that on our calculator and press equals. I hope that helps. Go on to Maths Online. You'll see there's some questions that I've set that have some index laws, and you can practice some of them as well. Good luck with it.